In this part 2 of Basics of Functions, we're going to look at arguments and return values. So functions can be made a lot more flexible and reusable in a lot more situations when you supply arguments to them. So suppose I want to have a flexible countdown function. So I'm going to have this countdown, and the idea is that it's just going to give some series of numbers. So counting down from there to 1 and then say blast off. All right, so I could do something like this. This will count down from 10, and as long as it's greater than 0, we'll keep counting down and then blast off. So we could, looks like blast off. There we go. Let's make a little exclamation on there. So, but this always has to start at 10. So a way you can make this much more flexible is to take this variable here, the start variable. You can only put and you can only do this with variables, and move it into these parentheses, like so. And now, this is a partial statement. Okay, the right half now goes into the call statement. What this does is allows the value for this variable to come from the call statement. In the call statement, you will have a right-hand value. So, and it's helpful to think of this as a left-hand side and this as a right-hand side, because that's exactly how they're connected. When the statement executes and control jumps to this component, right, behind the scenes, this statement happens, and then control continues from there. So then we can use this to have different countdowns. For example, I can make another variable, and I can call the function again with a variable instead of a literal. And I'll get a different countdown. Now I'm going to get 2. The first one starts at 10. The second one starts at the value of this variable, which is 5. So see, the same code executed twice, once with start equal to 10, and then again with start equal to countdown from. You can also accept a value from the user. See how that looks? So I want to count down from 20. Okay, and there you go. Another way we can make functions reusable is to have them calculate a result but not print it. Instead, deliver it back to the caller. So suppose I want to add up the numbers from 1 to 4. And I can have a function for that. That works like this. And that'll do it. All right, so we see what that looks like. Some of the values from 1 to 4 is 10. All right, but this only adds up some of the values from 1 to 4. All right, so we know we can make this more flexible already by setting an argument. All right, so I'm going to change the name slightly. Instead of sum 1 to 4, I'm going to call it sum 1 to n. and I'm going to pass the 4 as an argument. All right, now this also changing the name in the call also requires changing the name of the definition. Right? And right, whenever there's an argument, treat it as a right-hand side. So there has to be a matching left-hand side in the function header. So I'm going to call that int stop val. And then instead of using a constant here, right, I'm going to use the variable and modify this a little bit so I'm going to comment out the countdown stuff so that we can go straight to our sum function. And sum 1 to 4 is 10. All right, so let's try that out on a few different values for, let's say, 5 and 10. Okay, so we have one little problem. There's no line ending in the output statement. All right, so we'll fix that. And there we are. So, suppose now I don't want to print exactly in this with this context, or maybe I'm not going to display the result at all. Maybe I'm going to use the result in further processing, right, that this function doesn't know about. So it's very common now, as well as sending information into a function, we can also send a result back to the caller. So the way that works is we say explicitly that the function is going to return, so it's not going to be void anymore. I'm going to say, no, this function returns an int. And then instead of printing the result, I'm going to return it. All right, so this is a new statement that says, well, I don't really know what you're supposed to do with this, but I'm just going to deliver it back to you. And then that value gets delivered as a right-hand side back at the call statement. So we have to have a left-hand side to match it. All right, so I'll have maybe a variable here, int sum 1 to 4 equals. So now the call, because it's not void anymore, because the call returns something, the call statement goes to the right-hand side of an assignment, and you need a variable on the left to capture the result, like so. So when a function returns something, the call will be on a right-hand side of an assignment statement. And there will be some particular variable within the function that matches that type. And that'll be the last statement in the function that delivers the value back. All right, so now this will work just fine. All right, but there's no longer any output. All right, the result is delivered here, but it's not printed. All right, so if we want to print it, all right, I have to display the value there. All right, so stop value here was 4. So that does reintroduce some redundancy, because obviously we have to have 3 statements, but there's other ways we could address that. And it often is very desirable to have a result come back to the caller to be handled there for further processing, whether that's output or subsequent computation. So that's a look at arguments and return values.